Thank you all for joining us for our live PhyPrep demo. My name is Chris, and I am the market segment manager here at Biotage. I will be the moderator today for this live PhyPrep demo. I would like to introduce today's presenter, Dr. Hoang. He's our senior application scientist here at Biotage, and he has been with us for about 20 years. He has been involved in developing both the PhyPrep system and PhyPrep consumables from the beginning and is our go-to expert for this product line. Without further ado, live from our application lab in San Jose, Dr. Lee.
Hello, everybody. Good morning. Thank you for coming. Again, my name is Lee. Behind the camera is my colleague, Chris. We've been with this company for quite a while. We actually cut our teeth on protein purification using PhyTip columns for 96 at a time purification, where we bolt onto Hamilton and TCAM Beckman robots using our PhyTip column consumable for purification of antibodies, recombinant proteins. And it was really through conversations with our users, walking the halls, that we found that there was a need for fully automated plasmid purification. We found that the manual kits that are on the market were just not suitable for the current modern needs of plasmid purification. So that's why we're here today, and I'm really happy that you're here. I'm going to introduce our PhyPrep system along with our consumables for fully automated Maxi, Mega, and Giga plasmid DNA preps. This will give you yields of 1, 5, and 10 mgs respectively. Today, I'm going to show you a Mega prep because that happens to be what I have in the freezer in terms of cell pellet. And I'll be showing you how to prep samples using our system, and hopefully we can have a good time with this interaction through questions and polls. Actually, let's, Chris, what do you think? Should we start our first poll question? What scale of plasmid purification do you currently run? Do you run Maxis, Megas, or Gigas? Or are you kind of new to the purification side of things and you're mostly doing outsourcing? We'll let this poll run a little bit, kind of see some interesting results. From my point of view, we can see that it's kind of split. We're doing maxis and gigas mostly, so not a lot of folks doing megas, but that's what I'm going to show today. So we'll just have to be flexible. The good thing is that what I'm going to show you today is actually not any different between the three scales. All we do is we have different volumes of buffers, and you provide the cell pellet of different mass, and the prep's essentially the same. So if you learn how to do Mega today through this live demo, you'll be perfectly capable of running Maxis and Gigas as well. So I think the best way to show what we're talking about is just jump right in. So I have a E. coli pellet here. I scooped out 4.5 grams of E. coli pellet just from a frozen pellet that I had. And here are part of our consumable buffer system. We have resuspension buffer, lysis buffer, precipitation buffer, and RNase A. This is very standard kind of buffer systems that you would see in a manual kit, for example. The only difference is that we're trying to keep the volumes relatively low and small. Let's see. So it sounds like we might be having some issues with microphones. Let's see. There's an echo. Okay, we're good. Yeah, I'm just checking as the questions come in, I'll be able to see them. I see somebody here has said that they run gigas a lot. So yeah, please feel free to use the question system and I'll be able to see them, and also Chris will be able to catch them and then flag me to run them. Okay, so what we really like about this system is, as you might know, it's about 6 o'clock in California. I was in hair and makeup about 5 in the morning. So this is what I really call a pre-coffee activity. You can set up these preps, and hopefully you'll see that even in my state of lack of sleep, I'll be able to do this just fine. So here's our resuspension buffer. One thing that we really wanted to do to accommodate people like me is to have color coding. And so all of our buffers, you can just grab them off your shelf. This is resuspension buffer. It's with that red label. Our RNase A. We have RNase A that's lyophilized, and so we just dump that into our system. I have my handy garbage can off camera. Close this up. And so I'm shaking it near my microphone. I hope you can hear. There's some glass beads in there. It's neutral glass beads, and we put those into our system mostly because we wanted to have an easy way to resuspend pellet. We have a little check mark here says that we've added our RNase to our buffer. So in the event that, oops, we have to take a phone call, you put everything in the fridge, you remember that you did add your RNase. Here's my 4.5 grams of E. coli. This is DH5 alpha. We're expressing a plasmid that's basically GFP off of a CM promoter. Pretty standard. We did most of our development work on something that we thought would be most similar to what you might be running for like antibody type production lab. So to close that up, give this a good shake. All I'm really doing is trying to get a homogeneous sample. I want to make sure that everything is in solution so that we can go to the lysis step and have a good lysis condition. Yeah, so I just take a look at the camera or the lights, and I can see that it's pretty homogeneous. So like I said, we have 4.5 grams of cells here for our mega prep. Our lysis buffer can accommodate up to 7 grams of cells. That's what one of the hallmarks of our product is. We want it to be very flexible and very robust. Some labs might be growing very dense cultures, some labs might not. Right now, I'm going to be rather gentle, and I'll just invert this about 20 times. We have a color indicator dye, and so you can see the sample has changed color to a blue color. That indicates that we have a pH change. I'll do this inversion about 20 times. I don't want to overlyse. I don't want to vigorously mix, mostly because I don't want my double-stranded plasmid DNA to turn into single-stranded circular. So the copy number of our plasmid, I see a question here, is a high copy plasmid. And so we don't measure an OD. We find that it's much easier for us to measure cell pellet wet weight. And we're happy to have a conversation with you about that. So for us, the optimum cell pellet wet weight to get 5 mgs of plasmid from mega prep is 4.5 grams. But if you're running like a medium copy or a low copy, you can go up to 7 grams and be able to use your lysis buffer here. So I've just added my precipitation buffer, and as you can see, all of our buffers are color-coded, pre-aliquoted, so there's no measuring. It took about 4 inversions, and I was able to get the color neutralized. That means that we're in a state where the plasmid is happy, and we're not in any danger of anything falling apart. I see a question here. Let's see. So okay, what happens when you put in too much sample? That's a great question. So if we exceed the capacity of our lysis buffer, that means that we will not have enough lysis buffer to lyse all of your cells. Then we'll start to get negative results. We'll get a linear response in terms of recovery versus cell pellet input, and then it drops off because the unlysed E. coli will then compete for binding sites on our DEA column. And so in that case, we would see negative results. However, because we have 3 different kits, if you exceed the capacity of our Maxi prep, we just recommend that you go to our Giga prep. So that's the way we get to that. So next step we do is we pour our sample into our sample filter reservoir. And so to automate plasmid purification, we knew we needed to avoid centrifugation. And so one way we did that was to use this. So what we're doing is we're doing a crude filtration of our lysate. So I just simply pour this into my container. I'm ready to do the purification. I just set it up on my deck. Yeah. All right, so what do you think? That was my pre-coffee activity, and I'm all set up to run. I'll put this on my deck. So Actually, it might be a good time now that we can everything's in a good spot. Let's take a poll question. How many preps do you run in a week? Let's see. 16 plus for other folks, so quite a range. So I think uh, for everybody that answered the poll, this is a pretty good system for being able to do your preps. Okay, so I'm going to change gears now and talk about the system. So unlike our 5-tip column products, we were really like focused on 96 at a time purifications, but those are small volume. And so for plasmid purification, as you know, Maxi Mega Giga preps are quite large volume. And so when we developed the consumable, we knew that we needed a system to be able to process that full volume. And so that's why we developed this PhyPrep. We couldn't use an off-the-shelf system because we needed the capacity to be large. And so this is a dual channel 50 ml head. So we'll process 2 samples in parallel, but we have enough space on our deck to set up for 4 samples. So it will simply run 2 samples and then in sequence run 2 samples. So the user can set it up and walk away and be able to get 4 samples at the end of the run. This, in terms of the system, we wanted robustness. We wanted something that was non-intimidating as well. And so for robustness, we have very large motors, we work with very reputable vendors for our system. We have an aluminum deck that we can use, we can clean, keep an endotoxin-free environment. We have a drip tray here that can catch spills, and we have a panel PC plugged into the system and a vacuum carboy below the bench here with a vacuum pump. And so everything plugs into this system, and this system plugs into one position in your wall outlet. We have stainless steel. Uh, this is our wash buffer reservoir. So everything that you need to keep the system clean. We have this door. The door is hooked up to an emergency stop. So if there's any issue, you can open the door, the system will stop immediately. But for the purposes of this demo, we have to actually run it with the door open so you can see. I have a question here. How long is a 2-prep Giga prep run? So 2-sample Giga prep will take about, we have it as 175 minutes to run the prep and 77 minutes to run the concentration. So the total runtime is about 4 hours, a little over 4 hours. Okay, so I'm going to switch gears now and show you our software. So everything that I've told you now in terms of how to clean the system and how to set up your samples is also in this software, and I'll show you what I'm talking about. So when I go through the software, I can click here to start. I'm going to select Mega Prep, as we talked about. I'm choosing to do 1 sample today just for simplicity, but you can choose up to 4 samples. And today we'll be running purification and concentration. What I'm going to talk about as the system runs is the difference. But what we do is for purification, we're running an anion exchange resin, and then concentration, we're going to concentrate what comes off of that purification process. And then we have a couple of choices based on the capacity of what our concentration column can do. So the first thing that we would do is clean the deck and the nozzles. And so if you forget because you haven't used the system in a while, you can watch our video. If you have somebody new to the lab, a junior scientist, an intern, they can certainly look at these videos and be able to run the process very quickly. So we have these videos and nice animations. Next, I'm going to prepare the deck. So this is what I'm going to do. Oh, sorry, excuse me, prepare the samples. So this video essentially shows you what I had just gone through with our buffer system, our RNase, and our thawed cell pellet. So I'll give you an idea of what that looks like. So we've done that. Next, we're going to load the deck. And so the PhyPrep deck looks like this. We can pinch and pull, so we can pull to show. We're going to use transfer pipettes here, our concentration column there. These are the different positions that the system will use for endotoxin removal buffer, our Vexel column, equilibration buffer, the ethanol for the fully automated on-column ethanol precipitation step to concentrate, empty tubes, where our wash buffer goes, our second wash buffer elution, and final sample will be collected here. So this is set up right now for one sample. If we wanted to run 2 samples, it would be mirrored next to it. 3 samples would go here, and the third sample would go here. So I'll just go back very quickly to show you what I mean by that. So if we're going to run 3 samples, this is what the deck will look like. It's populated in kind of a mirrored form. Okay, I'm going to go back and choose my one sample. Yay. So this is my deck layout, and I use this all the time, even though I'm a daily user, and that allows me to do this. So in our deck, I just match what was on that screen to what I see here. So I have my pipette tips, different buffers, empty tubes, and then our collection tube will be here, wash buffer reservoir. And this is where we put our sample. So you can see that the filtration is filtering out the flocculate, and then on the bottom, we have our clarified lysate. All right, so let's take a minute to talk about kind of the heart and soul of our system, which is our chemistry. It looks like we have a question about where does the waste go? That's a great question. So under the system, we have a carboy. On the side here, we have some tubing. And so everything goes through the system. The carboy, we activate it with a vacuum. So we pull vacuum. As soon as the valves on the system open, it will pull whatever is in the positions here through, and that's where all of the waste goes. Okay. So I've talked about our Vexel column. So Vexel is a Swedish word. It means gear. So we named it Vexel because we're taking plasmid purification to the next step. We have a question here. How does the lysate clearing step work? Is it just physical removal through a filter? Yes, that's exactly it. When we developed it, we wanted something that was fast, but had sufficient clarification. It's not completely clarified, but it was sufficient enough to be able to be processed without any clogging. So this is our Vexel column. What we have here is packed with a DEAE resin. So anion exchange is a standard for plasmid purification. It's been like that for decades. And this is what's trusted most for the ability to clarify, to clear the endotoxin. And what's nice about the system is as you scale up with your molecule and you need to do production runs, you can still use DEAE. So what you learn at this scale is scalable for the next set of preps. And so it comes in a system like this. We just shake up the bag, open it up, and then we can add this to our system. So the DEAE is fairly straightforward. We use chromatography to purify our plasmid, but with any chromatography process, we're prone to getting some dilution at the end. And so the volume that we get out of our purification is usable by some folks, but for others, they really want that 1 mg per mil concentration. And so that's why we developed this concentration kit, and we're very excited. So we have a patent application out in Europe and just filed in Asia as well. This is what it looks like. I pulled one out here. So we essentially have a silica resin here. What we're doing is we're doing alcohol precipitation on our purified plasmid. Once the plasmid is purified and free of endo, we know that we can concentrate it using a high capacity resin. What we're doing is when we do normal alcohol precipitation, we'll centrifuge that, pellet it, decant, and resuspend. But the novelty here is that we're going to do the alcohol precipitation on the resin. The DNA will look for a surface. It will lay down on this surface. We're using our standard ethanol sodium acetate type chemistry. We can wash, dry, and elute in a very small volume to achieve that 1 mg per mil concentration. So Chris, let's actually ask a poll question. Let's see. how important is achieving 1 mg per mil concentrations? All right. And while that's going, there's a question here. Is the capacity for a Giga 2 prep per run or 4 prep per run? What is the time for the run for the 4 versus 2? So the capacity for Giga prep is 10 mgs for each prep. And you can set it up for 4 preps in a run. So you can get 4 different plasmids, each one at 10 mgs final. And a 2 sample Giga will take 4 hours, and a 4 sample Giga will take roughly 8 hours, a little bit over 8 hours. All right, let's take a look at these results about the concentration. Okay, so for a few folks, it's not important to get that 1 mg per mil, but for the majority, it looks like 1 mg per mil is quite important. Okay, great. So I've set up the system. We went through. I'm going to switch over to my screen and close this. So we just make sure that our deck is clean. We've prepped our samples. We've loaded the system. And there was a question about carboys. And so let's just take a look at that. So the carboy is where the waste is collected. That's under the system here. We have this vacuum here that will pull the air out. And so as soon as the valves open, a vacuum is pulled and we can pull the fluid through. So that's what we do there. And I'm going to start the run. And the system will always ask me, are you sure? I'll go ahead and start. And I'll switch over to here so you can see. So we can start to see some robot movements. So the head will home itself. The first thing that we're going to do is load a transfer tip and transfer some of that clarified lysate to our PhyPrep tube. So there is a question here about what is the capacity of each column. So the capacity is quite large for each column. What we know is that with these kind of purifications, we rely on Le Chatelier's principle. So we're trying to drive that binding onto the plasmid onto the column. And so if we have excess capacity, we'll be able to efficiently bind. So I've never really measured the capacity. We've kind of been doing these work empirically, but we know the capacity is much higher than what the yields that we get at the end, if that makes sense. Going back to the system, we loaded this 20 ml pipette tip. We'll actually move to the sample. Oh, I made a mistake. So what we're going to do first is add our endotoxin removal buffer. So we're going to aspirate here and move forward. So like I said before, it's very important for us to make sure that we have a system that will accommodate your workflow and your needs. So maybe we can run a demo or a poll question here, Chris. What growth media do you use? And so this question is important for us because what we're trying to do is have a buffer system that is quite robust. We want to be able to accommodate what you're growing. And so folks that are using rich media, for example, and very dense cell pellets, we want to be able to accommodate those. And so have a system that works for your needs. So it looks like a kind of a pretty large distribution of folks that are using a rich media and some folks that are using LB. Chris and I in graduate school, LB was the standard. Okay, so I'm going to show you what the instrument's doing right now. It's basically doing nothing because we're in an incubation step. We added our endotoxin removal buffer, and now we're in a pause state to just let that incubate. I'm going to switch over to the software here. So the software has been running for 2.5 minutes. This prep will be 2 hours and 45 minutes. We're in incubation here. If you ever needed to pause the system, this is what you would do here. You would pause the system. The system would be in a state where then you could open the door safely. You can close the door and then resume. I have a question here. Do you have both purification and concentration in one run, or can it be separated? Oh, that's a great question. It can be separated. For some folks, they don't need that second step to concentrate, so you can just run one. Or if you're running a plasmid that you don't really have a lot of experience with, you can run that plasmid, check the concentration of after your purification, and then be able to decide which concentration step, which concentration column you would need to do that. Okay. Oh, it seems like there's other questions popping up. What happens when you hit the end run button by accident? So the software is designed so that it always asks you if you're sure that's what you want to do. So if I click end run, it will ask me, are you sure you want to end the run? And of course you can end the run, but if you did it by accident, you would simply just press continue run. And once you do the end run, you won't be able to recover from that. So it'd be kind of some kind of failure that you knew you needed to stop because you wouldn't be able to resume the run after you ended it. If you want to do that, you should use the pause button. Okay. So for the Maxi Megas and Gigas, we're able to purify the sample. We can purify a robust set of samples. Folks that are using our products are really producing antibodies, producing AAVs, we found out. And there's quite a bit of folks that are using our plasmid, the plasmids off the system as templates for mRNA production. And so there's a because of those needs, things are a little bit specialized, and so that's kind of one of the drivers why we knew we needed to make this system. Um, for folks that are running, let's say, antibody production that eventually will go into a system, let's say some kind of study, I know that endotoxin might be very important. So let's run a poll question, Chris. How important are endotoxin levels for what you're running? From my conversations with people in the field, some folks it's very important. Some folks, they just need a working amount of expression, so they don't really measure. Yeah, it's very interesting. Looks like why don't we share these results? Looks like everybody really needs that endotoxin to be low or no. So endotoxin levels are very important. Great. So so what's the level of the endotoxin in the final sample? So in our hands, with our model system, like I described, we're able to get less than 1 EU per microgram. And if you want to see how we get that, there is an app note next to the question box. That note has some materials that you can download. It tells you exactly how we achieve that endo-free. We're using TB grown in Thompson flasks with the baffles, arrow top seals, and we're able to get reproducible results there. Can you run the system overnight? So it's a really nice question. Definitely. So if you're running Maxi Prep, my caution is to run Maxi Prep purification overnight. But because when we concentrate, the final volume is about 1 ml or half a milliliter, it's too small to sit overnight. It will get too much evaporation. So Maxi Prep concentration, I would say no, but for everything else, you're able to run overnight. What we've done is we actually run samples in parallel. We take one sample out and do all of our analyses. One sample we left in the system overnight, and we analyze and we see no differences. And we've repeated that many times. So I just switched over to the robot now. So the incubation step is over. We loaded a pipette tip column. We're going to aspirate the semi-clarified lysate, and then we're going to transfer that to the first PhyPrep tube. We do some liquid handling here, trailing air gaps, things like that, so we prevent dripping. So we have a question here. Does the platform have API capability to enable controller lab management software like Momentum or Orchestrator, platforms like BioNemo, et cetera? We don't have that yet, but we'd be happy to have a conversation. Feel free to go to biotage.com. We'll connect you with the right folks to have that conversation. We'd love to learn more about that and your needs. and see if it's a good idea to go down that route. We have a question here. Can you do mini preps on this system? So no, we don't do mini preps on this system. For mini preps, our products are geared more towards like the Hamilton TCAN type system for 96 at a time. We find that the sweet spot for most people is folks that are doing, let's say, 4 plates of mini prep or more. Those are the ones that really gravitate towards our mini prep consumable, but they would then be processed on, let's say, a Hamilton robot 96 at a time. So we've now done our aliquoting. The next step, the system will then load our vexel column and do equilibration. We'll go through our capture, wash, and elution. And of course, 9-10 minutes ago, you would have been able to walk away and had your first coffee of the day. So hopefully you can see how the system works. And if there are any questions, maybe I'll ask our moderator, Chris, to scream through. Okay. We do up to 18 Maxi preps with one operator in 4 to 5 hours on the bench. Conventional columns. Could this be done in an automated way? So for Maxi preps, what's nice is that we can set it up for 4 samples, tear it down, set it up for the next 4, tear it down, set it up for 4 overnight. So definitely you can get through your throughput. The hands-on time, like you saw, was very little hands-on time. So in terms of actual run time, 4 sample Maxi would take about 3 hours. So you can get through, 12 in a day. So in some cases, it might make sense to have 2 systems, but with the hands-off time, that's really where you see some value. So your full-time employee can do other work rather than doing the manual preps. So we'd be happy to have a conversation and kind of map out how it would look in your lab and how it would be done. But in general, that's my recommendation, is to kind of have set runs, tear down, run, tear down, and then that's how you get your throughput. I have a question here. Does the system alert you when the run is done? So we don't have that capability to send a text or something like that to your cell phone. What we do is we just have this kind of method progress window, and so folks know about what time the prep will be done. But with the door closed and the system running, it's safe. You don't have to be there right when it finishes. It'll be available to you, and you can do other tasks while you wait for the preps to finish. I know we need to be sensitive on everyone's time, but I'm happy to answer questions. If you have other questions, reach out to us. Go to biotage.com. You can download our information that's on this here. I see some new questions have popped in. Oh, okay. So this question is, I have your generation 1 PhyPrep instrument. Is it possible to upgrade to this new instrument? That's really good question. So some of you might know that the PhyPrep was launched quite a while ago, 4 years ago or so. And from the feedback from those users, that's when we developed this concentration process. To run the concentration, there have been some upgrades to the PhyPrep 1 system, namely that's in the deck, in our waste management, and in the software, and obviously the consumable. But the good news is, if you have a generation 1 instrument, you can upgrade the system. We can do it on site for you. It takes about 4 hours or so. We'll get you a new power panel, new deck, valve system, software update, and you can be on your way. So yes, definitely can be upgradable. We have a question about, can you start your next run while the current run is going? The question is, the answer is yes and no. You can set up everything like I showed you and pour into your sample filter reservoir. But once this is done, that's when you have to tear down and then add those samples. So you can save some time by prepping everything, maybe all in the beginning of your day, and then just loading them as you go, so you don't have to rerun all of the preps. So We're now in our capture step. Might be hard to see from this angle, but we're actually going through our purification. I see a questions coming in. Okay, just to clarify, one system does all three scales, Maxi, Mega, Giga. That's correct. So this system can run Maxi, Mega, and Giga. There's no additional components or anything. It's very nice for people that have become, let's say, more efficient with their expression. They can start out at Giga preps and produce a lot of plasmid. As their expression system gets improved, they might only need Mega, and so they would then scale to Mega. The benefit of then having higher throughput. So that's one system, same software, same setup with all of our buffer system, just different volumes in the pre-aliquoted bottles. There's a question here, is the maximum capacity per run set at 4 Maxi or 4 Mega or 4 Giga? So the maximum number of samples that we can run on the system is 4 Maxi or 4 Mega or 4 Giga. But we can't mix and match. So you can't do, let's say, 2 Maxi and 2 Mega in the same run. So they have to be two independent runs. Oh, it looks like that was a question. Is it capable of doing a mixed configuration, 2 Maxi, 2 Mega? No, so it can't do that. Well, this has been a lot of fun, being able to share all of our work with you, and answering your questions. I know that we don't always get to answer everything, so please email us at the end when you things come up. We'd love to connect with you, and show you this live in person. And so it's been a pleasure. I'm gonna switch it over to our moderator, Chris, and see if he has any final thoughts.
Thank you, Dr. Lee, for the wonderful demo today. Um, our type is over today for today. I'd like to thank everyone for attending this live PhyPrep demo and hope you have a rest of the wonderful day today. Thank you, everyone.